Hello students, I am Arshith, lecturer in Computer Science, Alpha PU College, Nagar. In this video session, I'll be talking about the very first chapter of your second PU academic, which is the typical configuration of computers. This chapter holds a weightage of marks of 4, where you get one question from the segment 3 marks and one question from the segment 1 mark. You can expect more like abbreviation questions from the segment 1 mark. And before starting this chapter, I want you all to know that this chapter is an extension of hardware components what you have already studied in your first year PUC. Since this is my very first video class, I shall start the class with the definition of computers. Computer, what are computers then? Computer, it is an electronic device which accepts input and results in the output. So basically, why computers are used? Computers are used to ease the work of a person, a particular person. We call that particular person as user of the computer. Okay? Fine. Now we got to know what is computer. Computer is an electronic device. It accepts input and results or produces the output. Now, what are the requirements or what are the things which are required to make a particular device which is called as computer to work, to make it work? So that required things I call that things to be components. Now, what are the components of computers? Components are like required things to make a computer work. So what are the components then? I shall go with the definition for the answer of components. So what does definition states? It is an electronic device. It states it's an electronic device. So I believe you remember, you have heard the word devices in your first year PUC. What does a device mean? Which means it's a physical part or an hardware, right? So very first component of computer or very first thing which is required to make a computer work is the hardware. So now what is in hardware? So hardware, how can I define hardware? So hardware is an physical part or a device which we can feel, touch or sense. Now hardware, it's a machinery part. We know that hardware, it's a machinery part. It doesn't work all by itself. So it requires some instructions to be or to get worked. So who gives instructions? I cannot give all the time going to the machines or going to the hardware parts, and I cannot give instructions all the time. So to make it work, to make it get worked as per the requirement, I need to instruct these machinery parts. I can do that with the help of softwares. Now what are softwares? Softwares are set of instructions or set of programs. Okay. Now this being two components. Now I shall return to the definition again. So it's an electronic device. From device I got hardware. So from this hardware I got to know I should have a software to make this hardware work. Now further moving with the definition, which accepts input and produces output. So which accepts input in the sense someone has to give the computer some inputs. So that inputs we call to be a data. Now how can I define a data? So data, I can define a data like it's a raw fact which has a partial meaning. Now what is that? What does that mean, partial meaning? So partial meaning in the sense it has got some meaning but not with the complete sense. So I shall talk about that bit later when I come to this functional units of computers. Okay. So data, what is a data? Data, it's a raw fact or it is a fact which has a partial meaning. Fine. So the last component of computers which makes a computer to work is user. Now who is the user? The one who uses a computer is called as user. As per the definition, these are the requirements, or these are the components. I got it from the definition. It's an electronic device. I took the device, I got hardware. Hardware doesn't work all by itself, so I got software which accepts input. So from input I got the data. Who gives input to the computer? The person, one who uses the computer, right? So the one who uses the computer, we call him to be user. Fine. So these are the components, 4 components of computers. Now we got to know what are the required things to make a computer work. Further moving, using these components, how can I make a computer work? How a computer works then using these components? So these concepts are explained using functional units of computers. So work, the word work we call to be functioning or function. So functional units of computer defines what are the units or what are the components which helps to make a particular computer work and produce the output based on the input given by the user. Okay, so functional units of computers comprises of 3 major units: input unit, output unit, and central processing unit. In short, we call it to be CPU. Fine. And again, CPU, it's a main whole thing. So this CPU comprises of subunits: memory unit, control unit, arithmetic and logical unit. So memory unit is used to store the data or information or a particular program, where if you have to store something inside the computer, so memory unit helps in storing that data or informations. ALU, arithmetic and logical unit, this unit helps in calculations, sort of, or calculations in the sense arithmetic operations or comparisons, any sort of calculations carried out using ALU. Then what the use of control unit? Control unit controls the flow of data from input unit till output unit, moving all the units inside the CPU. Fine. Now using these units, how a computer works then? So these are the components required, very much required to make a computer work. So using these components, I derived functional units. So softwares, hardwares are input devices, output devices, CPU, those are the hardware things. Data, I shall let you know. User, I shall let you know. Softwares, to make the data move around the units, we require sort of softwares. Now using these functional units, how our data is processed or how our data is fed into computer and given out the information. As a user, I input data. Okay, before this, I believe you all remember input unit and output unit, which you have learned in your first year PUC. Input unit comprises of input devices and the data produced from input devices. In the same way, output unit comprises of output devices plus information or data produced from that particular output devices. Now as a user, I input data using input devices which is present in input unit to the CPU. CPU takes the input what is given from the input devices. Control unit controls the flow of data, as I said earlier. It takes the input, it checks for the data whether it has to be stored or it has to get calculated. If it has to be stored, control unit takes the data and places or stores in memory. And if it has to get calculated, control unit takes the particular data from the memory and stores and places into ALU where it get calculated. And if any results are produced, again the results are placed in memory unit. Anything, the data or information, it has to be stored in memory unit. When I say memory unit are divided into two parts. One is secondary memory and another one is primary memory. Primary memory is also known as main memory. So I hope you have learned, and I believe you remember RAM, ROM and all. So RAM, ROM and all belongs to primary memory, which is also called as main memory. Okay, so data is flown from all the units inside the CPU, and if the result has to be produced, so the result is produced using output devices, which is present in output unit. Now data, when I said data, when I defined data, I said it is a raw fact which has a partial meaning. Let me give you an example for this. So I input a number 20. As a user, I give the computer the number 20. Now 20, it is a value, it has a meaning, it is a value, but I don't know what sort of value it is. Does this value belongs to weights? Does this value belongs to marks? Does this value belongs to some measurements? I don't know. I have no clear picture, but still I have the meaning for this. This is a value. This has some value 20. When I give this 20 using input unit to the CPU, control unit takes the number, stores the number in the memory. Fine. Now if I want to get the output, for this particular number, suppose if I want to add two numbers 20 and 30, I give two numbers. Now 20 is an individual number, 30 is an individual number. I give this number to the CPU. CPU stores 30 and 20, control unit with the help of control unit. Later control unit takes this 20 and 30, places in ALU where calculations happens, 30 plus 20, which produces a value 50. Again 50 is placed using control unit into the memory. Further, the result is shown in the output devices or output unit with the help of monitors. So the sum of two numbers is 50. Now this 50 is a value, or the sum of 30 and 20 is 50. Now 30 is a value, 20 is a value, 50 is a value. Now these three values can be seen in output with a proper meaning, sum of two numbers. So now it is a number, it's not a measurement. So when I give a number, particular number 20 and 30, now I have a confusion that is it a number, is it a measurement, is it a weight? So I have sort of confusions, but when I get a result, I got to know that it is not a weight, it's not a weight, it's not a unit, so it's just a number, and I have to add those number, I got a result. So this output we call to be information. Now how can I define information? Data, when I say data, it is a raw fact which has a partial meaning. Now when I come to this output part, the result is produced. The result, I call it to be an information. Now how can I define an information? Information, it is a collection of data which has a complete sense of meaning. Okay, so this is how the functional unit of computer works. Okay, further moving, we shall know what are you have already learned about input devices in input unit, output devices in output unit. Now in this chapter we shall learn what are the components present inside the CPU to make a particular data to get processed. Okay, from functional units of computers, we know that there are components related to input unit and the components related to output unit. From now on, we shall know the components related to the CPU. CPU comprises lot of components. So all those components has to be kept so that in a particular way, so that the data can be flown correctly. Okay. Now all those components which are related to the CPU are kept in a particular board in a form of circuit. So why the circuit form? Because to transfer data or to make a data flow correctly from one component to another, it has to make a circuit form. So all the components are kept on the board or placed on the board or mounted on a board in a circuit form. Okay, so that particular circuit board is called to be a motherboard. So motherboard is a board where all the components of computer are arranged or placed in a circuit form. Okay, so how can we define a motherboard? So motherboard, it is a printed circuit board. Why it is called circuit board? I already talked about that. So where all the components of CPU are mounted. So components, something like slots, ports, buses, controllers, etc. So all these sort of ports are mounted, components are mounted on a board which forms a circuit, and that particular circuit board is called to be a motherboard. Okay, next, characteristics of motherboard can be characterized by these three factors, these three things. So characteristics of motherboard can be defined into these three things: form factors, chipset, process socket. What is a form factor? Form factor defines the geometry or the dimension of the motherboard. So how big or how small the motherboard is. So the bigger the motherboard, the more equipped or more components can be placed or mounted onto it. So form factor, it tells the dimension or the arrangement and electrical or electronic requirements of the motherboard. Okay. Next, chipset. Chipset, it controls majority of the components and its functionality is to coordinate data transfer between various components of the computers. Coming to processor sockets. Processor sockets is a place, or it's a place where the processor are placed. So processor sockets can be placed in two ways. So processor having rectangular connectors can be placed vertically onto these processor sockets, and processors having square shaped connectors can be placed or mounted onto these processor sockets directly. So these are the three factors or characteristics of motherboard. Okay. Based on these characteristics, motherboard can be classified or categorized into 4 types. So what are those 4 types? XT motherboards. So XT, extended technology motherboards. So it's an old form of motherboard. It is an old model motherboard. It had old model processor sockets. That processor socket we call to be LIF sockets, low insertion force. So this is a processor socket a processor socket in the sense where a processor can be placed. So, and it had a main memory, DIMM RAM, dual inline memory module. So all these abbreviations are very much important. Please do note this. DIMM, dual inline memory module. So it's a main memory. So it also had ISA, so industry standard architecture. So it's a form factor, and it also had 12 pin connectors, and it had no ports. So what are ports? So we shall discuss in further classes. And example for XT motherboard is Pentium 1 and 2. So it's a processor. So we recognize particular motherboard with the help of processor. What type of processor we use on that particular motherboard. By the processor we define what sort of motherboard we use. So XT motherboards have example for XT motherboards are Pentium 1 and 2 processors. So coming to the next type of motherboard, AT motherboard, advanced technology motherboard. So this motherboard had PGA sockets, PGA pin grid array sockets, SD RAM, synchronous dynamic RAM, it's a main memory. So RAM slots in the sense where the RAM can be placed into the motherboard. So it also had 20 pin connectors, where it had 12 pin connectors, power connectors. So it has 20 pin connectors, power connectors, PCI and ISA slots. PCI, peripheral component interconnect. So full forms is very much important. PCI, peripheral component interconnect, ISA, industry standard architecture slots. So example for AT motherboard is Pentium 3. So Pentium 3 processor. And coming to the third type of motherboard, baby AT motherboards. Baby AT motherboards are a combination of XT and AT motherboards. So this motherboard, baby AT motherboard, had a common features from XT and AT, also some additional features, so additional components, sorry. So it's a combination of XT and AT. It had 12 and 20 pin connectors, power connectors, and slots, and ports. It had ports, it's not slots, it's ports. It also had ports. So it had PGA pin grid array, SD RAM, synchronous dynamic RAM, and it also had additional main memory, that is DDR RAM, double data rate random access memory, and it also had PCI slots and ISA slots. Okay, example for baby AT motherboards is Pentium 3 and Pentium 4 processors. And last type of motherboard is ATX motherboard. So ATX motherboard is a latest form of motherboard. So it is designed by ATX form factor, and it had MPGA, multi-pin grid array processor socket, and it has DDR RAM. DDR I already talked about that. Double data rate RAM. So we shall know about this in further classes. And also you have learned these RAMs, main memory and secondary memories in your first year POC too. So it had PCI slots, AGP slots were introduced in this ATX motherboard. AGP, accelerated graphic ports, primary and secondary IDE interface, IDE, integrated digital electronic interfaces were introduced in ATX motherboards. It also had 20 and 24 power pin connectors. So examples of ATX motherboards, you can go with the latest form of processors, i3, i5, i7, dual core, and you can come up with any examples to this ATX motherboard being a latest versions of processors. So this completes my class 1. The rest of the topics will be discussed in later video classes. Thank you.